Question number 8. Figure 8.1 shows a circular metal disc of mass 200 gram freely pivoted at its center. Masses of 100 gram, 200 gram, 300 gram, 400 gram, 500 gram, and 600 gram are available, but only one of each value. These may be hung with string from any of the holes. There are 3 small holes on each side of the center. One at 4.0 cm from the pivot, this hole and also this one. One at 8 cm from the pivot, this hole and also this one. And one at 12.0 cm from the pivot, this one and this one. The apparatus is to be used to show that there is no net moment of force acting on a body when it is in equilibrium. Question 8a. On figure 8.1, draw in 2 different value masses hanging from appropriate holes. The values of the masses should be chosen so that there is no net moment. Alongside the masses chosen, write down their values. There are some possible correct answers for this question, so your answer can vary. The important key to answer this question is make sure that the mass times distance for the left side of the pivot equal to the mass times distance for the right side of the pivot. As an example, I choose 300 gram and 200 gram masses. The problem now is where to put these masses. After you determine which masses you want to use, find the LCM or the lowest common multiplication of your masses. My masses are 300 gram and 200 gram. So, the lowest common multiplication for my masses is 600. That means we have to put the 300 gram on the second hole and the 200 gram on the third hole. You can exchange the position of the 300 gram and the 200 gram. So the 300 gram can be on the right side and the 200 gram can be on the left side. But still, you have to put the 300 gram on the second hole of the right side. And the 200 gram must be put on the third hole of the left side. And also, you have to remember, you are only allowed to put one mass on each side of this center. If you put both masses on the left side or both masses on the right side, you will not reach equilibrium condition. Why the 300 gram must be put on the second hole? And why the 200 gram must be put on the third hole? The answer is because 300 times 2, there are 2 holes from the position of the 300 gram until the pivot equal to 600. And 200 times 3, there are 3 holes from the position of the 200 gram until the pivot is also equal to 600. Question number 8b. Calculate the moments about the pivot due to the 2 masses chosen. The answer to this question is based on your choice in 8a. So, I will answer this based on my choice in 8a. First, convert the masses into kilogram. To convert the masses into kilogram, divide each of them by 1000. Then, the 300 gram will become 0.3 kilogram and the 200 gram will become 0.2 kilogram. Because moment is force times distance, we must convert the mass into weight. Just multiply each mass by 10 to get the weight of each mass. So the 0.3 kilogram becomes 3 Newton, while 0.2 kilogram becomes 2 Newton. Next, multiply each weight by the distance about the pivot. We have to go back to the figure to see what are the distances for each weight. We can see here that the 300 gram is 2 holes away from the pivot. So, the distance of the 300 gram from the pivot is 8 centimeter. The 200 gram mass is 3 holes away from the pivot. So the distance of the 200 gram is 12 centimeter from the pivot. You can see the distances of each hole on the problem here. The SI unit of moment is Newton meter. Therefore, I will convert each distance from centimeter into meter. The distance of the 300 gram mass from the pivot is 8 centimeter, which will become 0.08 meter, while the distance of the 200 gram mass from the pivot is 12 centimeter, which will become 0.12 meter. Remember, just divide the number in centimeter by 100 to convert it into meter. So, the moment due to the first mass is 3 times 0.08, which equal to 0.24 Newton meter. While the moment due to the second mass is 2 times 0.12, which equal to 0.24 Newton meter. Both moments must be equal. Otherwise, your answer in 8A is wrong. Now, let's fill in the answer to the provided space. Moment due to first mass is 0.24 Newton meter. Moment due to second mass is also 0.24 Newton meter. Number 8C. Calculate the force on the pivot when the two masses chosen are hanging from the disc. The force on the pivot equals to the sum of the weights. The weights are 3 Newton and 2 Newton. Then the force equals to 3 plus 2 or 5 Newton. This is the end of the mid-exam discussion. If you have any question regarding to the discussion, you can ask me directly in the next week. Next week, we will have Zoom meeting, so you can ask anything about this during the meeting. See you next week. Bye guys.